All right. So I'm going to be going through the review for Unit 8 in case you guys need some support on any of these questions. I'm not going to spend too much time going into deep detail unless I think it's going to be really helpful for you guys. But for the most part, I'm just going to go really quickly to remind you of what you guys should already know, and then again, anything that I feel like will probably be a little bit more tricky, I'll make sure I point it out. So this box right here is just practice from day one using the formulas, really straightforward. On the quiz, I made sure that I underlined and highlighted the important words to look out for. That won't be true on the test. You guys really need to make sure you're looking carefully for the words. The words in particular you need to look for are sum versus an or individual angle. So you're looking for all of them added together or just one, and then interior versus exterior. So for this first question, I see sum and interior. So those two words tell you which formula to use. I want the formula for the sum of interior angles, which is 180 times n minus 2. You have to have all four of those rules / formulas memorized. Otherwise, you're just going to have so much trouble with these. So now on the sum of interior, I'm going to do 180 times the number of sides minus 2. This is a nonagon. You have to remember a nonagon has 9 sides. So it's going to be 180 times 7. 9 minus 2 is 7. So when you do that, you get this as a result. So you just got to know the formulas. The rest of it is very simple. This one, I see the word sum and exterior. So this time I'm using the rule for the sum of exterior angles. There's no formula for this. It is the same answer every time. When they want the sum of exterior angles for any shape, it is always 360. So as soon as you see this and this, you don't even have to pay attention to the fact that it's a 109 gon. It doesn't matter how many sides it has. The answer is always 360 for the sum of exterior angles. These questions are different. I don't see the word sum anywhere in here. Instead, I see each interior angle. So when you want each individual interior angle for a regular polygon, remember this only works if all the angles are the same, which is going to happen in regular polygon. We're going to be using this formula, the second one that we memorized. The only difference between this one and this one is that you divide by n to find one angle. So it's taking the sum of all of them together and dividing by n to find just one of them. So it's the only difference. Just got to keep that straight, whether it's the sum or the individual, which formula to use. This is a 30gon, so I'm going to plug 30 in for n. So it would be 180 times 28 is in the numerator, because it's 30 minus 2, and then you divide by 30, because that's how many sides you have. The number of sides is the same as the number of angles. So you find that number in the numerator, and then you divide that by 360, and that would give you 168. Okay, so again, straightforward use of the formula, you just need to remember what it is. And then this one, find the measure of each exterior angle of a regular 45 gon. Again, you have to look for the word regular in order to use those formulas. And remember, anytime you see each, you're trying to find just one angle, you take the formula that you originally knew for the sum and you divide by n. That's the only difference. If you're trying to find one interior angle for a regular polygon, you just divide it by n. And so for a 45 gon, n would be 45. So it's 360 divided by 45, which is 8. Okay? So that's really just, it's pretty straightforward. Just know your formulas, know how to plug them in. Remember that n stands for the number of sides or angles, depending what they're asking, and you just plug it in. Now the next questions underneath that, 5 and 6, they're the same type of question, they're just solving backwards. So for the first set, they gave you what n was, and you plugged it in to find the angles. This time they're giving us the angles, and they want you to solve backwards or undo the formula to solve for n. So again, look for the keywords. So find the number of sides of a regular polygon if the sum of interior angles is. So I'm using that same formula, the sum. The keywords tell you what formula you're using. It just depends on how you're using it. So I have this formula. That's the one I know I'm working with here. I don't know what n is, so I can't plug it in like I did in the previous questions. Instead, I know what the result would be. I know the result. If I had n and plugged it in, this is what I would get. So now I'm just solving backwards. This is that backwards direction. So what you would do is you divide by the 180, which gives you 6 if I remember correctly. And then you add 2 to finish solving algebraically. This has 8 sides. N stands for the number of sides. The result is 8. 8 sides. Same thing over here. sum of interior angles, that's this formula. Oops. And I know that the result is this, because they told me the sum is this number right here. In order to get that number, I have to use this formula. I just got to figure out what n would give me that. In order to do that, I'm going to solve backwards, or solve for n. So I divide, and I get 20. And then when I add the 2 over to get n by itself, 22. So again, really straightforward. You just got to know how to solve for n there. And then this one again, find the number of sides of a regular polygon if each individual interior angle measure is blank. Again, I see each interior. When you see those keywords, I'm using this formula. This one. Each interior, that's this formula. And I know that one interior angle is this. I just need to figure out what n gives me that number. And this is how you would solve this question. You solve backwards. So we're going to multiply the n and distribute. And I'm going to run out of room. I'll write this one further over. Alright, so remember algebraically, when we did this in the notes, we multiply the n over and then we distribute the 180. It's easier to solve that way. Then I subtract this over, I get negative 18n because this number is bigger, so it becomes negative when you subtract it. But then this number is negative, so when you divide the two negatives, it becomes positive, and I believe that's 20. Yep, 20. So the number of sides is 20 for that one. Okay, we're going to do the exact same thing for example B. They said that the measure of each individual interior angle is this. So I'm going to use the formula for individual angles of a notice how they also use regular. That's important to look for too. It's a regular polygon. I know it's equal to this. Okay, so now again, we're going to solve it the same way I did over here. I'm going to multiply the n and distribute. Okay, and then like we did before, calculator that just isn't decimal. I'm going to go ahead and subtract that over, so I have 168.75 minus the 180. You get negative 11.25n, and then you divide negative 360 by negative 11.25, and you get 32. So even though there were decimals to begin with, they should go away. When you guys are looking for n, that should be a whole number or something that rounds very closely to a whole number. So that's how you do these two questions. You know how to use those formulas by plugging in n, if you're given n, or solve backwards to find n. You have to know them forwards and backwards. So that was the day one material. Now, oh actually there's one more question from day one. There's also this question, number 7, that comes from day one. Okay, I'm looking for this angle right here. Now listen very carefully. I am looking for one interior angle. But this is not a regular polygon. So I know when you guys hear one interior, your instinct is to be, oh, we have a formula for that. You can use that 180 n minus 2 divided by n formula. No, you can't, not here. Remember that it's very important that if you're using that formula, you also have to see the word regular. You can only use that formula, the 180 times n minus 2 divided by n. You can only use that to find one interior angle if it's a regular shape. And you can clearly tell these angles are all different. So this is not regular. So instead, we're going to do that process that I showed you guys before. If I give you a triangle, and I showed you this, you would know really easily how to do that. You know that all those angles add up to 180, so you add these two and subtract. You guys are able to do it like that. This idea is the exact same for this question. It's just that these don't add up to 180, they add to something bigger. So you just have to figure out what that number is. Okay, what do they all add up to? Once you know what they all add up to, you can subtract the ones you know away, and that gives you k. Alright, so remember, for a triangle, you guys know automatically it's 180. You guys have been trained to know that. This is a 10-sided figure. You guys can count. There are 10 sides. You guys don't have them memorized because you don't see 10-sided figures that often. So remember, we have a formula for that. If you don't know what they add up to, triangle, you know, 180. 4-sided figure, 360. Pentagon, you may even have that memorized. What is that, 540, I think. 7-sided figure, 900. Some of them you may have memorized. But for a 10, if you don't have it memorized, there's a formula for that. Finding the sum of interior angles, that you can do if the shape is not regular. This formula works for any shape. Doesn't matter if it's regular, doesn't matter if all the sides are the same, angles are the same, this will always work. It's when you do this formula, the shape has to be regular. All the angles have to be the same. But this one, finding the sum, doesn't have to be, okay? So I'm going to figure out what all these would add up to by plugging in 10. So 10 minus 2 is 8. So then all of them, we did that before, now I've already forgotten. Okay. So using the formula for finding the sum of interior angles, which works for every shape, I know that all of these angles, all 10 of these angles should add to this, okay? But, hold on. Now what I'm going to do is I'm going to add all these together. I'm going to swap backwards here. So you guys can take a second, but add all of these angles together, everything except for K. Those all add up to this much. Okay, so the equation, I know that all of them should add to 1,440. I know that the ones that I have add up to this. Now I need to find K by just subtracting that. So K is going to be equal to 56. Okay, so when you guys see a picture like this, you cannot use that divide by n formula because this is not a regular shape. But you can still use this one. You can still use the sum to help you like you would if it was a triangle. Okay, so just please do not make that mistake with this kind of picture. Now we're going to switch to something else. So this is now an isosceles trapezoid. We're going to look at the isosceles trapezoid properties here. So I know this angle right here is 57. I know that this leg is 10, and I'm going to find a bunch of different information in this picture. The first one they want me to find is angle A. So angle A is right here. The relationship between angle A and the angle that I have is that they are consecutive angles or consecutive interior because of the parallel lines. So remember, the consecutive angles are the ones along the leg here. Those are supplementary because the lines are parallel. So if I subtract 57 from 180, I would get 123. Okay? Now they're also asking for angle C. Now if you look very carefully, they also said that I have a mid-segment drawn inside. And remember, a definition of mid-segment says that the mid-segment has to be parallel to the bases. So if I was able to find angle A by using consecutive angles with the parallel lines, I can do the same thing with angle C. It's like there are two trapezoids. You have a really big one, and then when you cut off the top and you just look at this right here, right, there's like, it's another trapezoid right there. So what's really interesting is that with the mid-segment, you can also find the angles around the mid-segment here, 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 and here by using parallel lines because they're parallel to the bases. So angle C is also going to be 123 because it is consecutive interior with that 57 as well. So that's something to remember. Angle D is a base angle. So these two angles of 57 and angle D, those are base angles, and for an isosceles trapezoid, base angles are congruent. So this is going to be 57. And then X is this little segment right here. Remember that the definition of mid-segment is that it connects the midpoints, right? So just like midpoint is right in the middle and it chops something in half, same thing for mid-segment. It's going to chop the two sides in half. So this right here is equal to it's been chopped in half here. And if this side is 10, remember the legs are equal. So that means that this whole thing is 10, but I only want half of that. So X is just 5. So I used two ideas there. I knew that the legs are equal because it's isosceles, and the mid-segment cuts it in half, just like a midpoint would cut a segment in half too. All right, so that's just a little bit of work with the isosceles trapezoid. We're going to see another question with that a little bit later. All right, number 9, we're going to be working with work with shapes in the order that we learned them. So I'm going to talk about parallelogram, then rectangle, rhombus, square, all those. So the first one is a parallelogram. They don't have a picture, so I'm going to go ahead and draw one. So I have A, B, C, D. I have angle ADC is X, BCD is 3X minus 8. So this is what they've given me. They want me to find the measure of X and the value of X and then the measure of that angle. So what I have to do is figure out what's the relationship between the two angles that they gave me. Well, obviously the 4 properties of a parallelogram, the opposite sides are equal, the opposite angles are equal, the consecutive angles are supplementary, and the diagonals bisect each other. So the two angle properties is that the ones opposite or across from each other are equal, and the ones that are consecutive or supplementary, these ones are the consecutive ones. So those are supplementary. So if I add them together, I just went ahead and combined the X and the 3X to get 4X. If you combine those together and then solve, x is equal to 47, algebraically. Take a second to do that yourself. But algebraically, x would give you 47 using that relationship. Okay, so then if they want you to find the measure of this angle, all you have to do is plug in 47. So you do 3 times 47 minus 8, and you get 133. So just as a follow-up, they wanted you to use the x that you found, plug it in, find that angle, and you're good to go. All right, other one. I'm going to draw another parallelogram. A, B, C, D. AD is 6x minus 4. BC is 2x plus 23. What property would best fit this? Well, take a look. We have opposite sides labeled, and for a parallelogram, opposite sides are equal. So I'm going to go ahead and write those two expressions equal to each other. And then you solve. So you subtract the 2x, you get 4x. You add the 4, you get 36. You divide and get 9. So x is equal to 9. And then when you want BC, you would just plug that in. So 2 times 9 is 18, plus 32 is 50. All right, really straightforward application of the parallelogram properties. All right, we're going to look at another parallelogram here. Now, be warned on the test, in the directions, they may not tell you what kind of shape it is. Sometimes they will. They'll say, here's a parallelogram, please solve. Other times, they won't tell you what shape it is. You have to look at the markings. Like, for example, if they wanted something to be a rectangle, they may say, they may do this. They may, here's the shape, please solve for x, or something like that, I don't know. But they're not going to tell you what shape it is, they're just going to put markings in there. And based on the markings, you have to figure out what shape it is. So just be warned that that's a possibility, so you have to make sure you know your properties well to understand what shape they're working with, so you don't accidentally call a rhombus a square, or a square a rectangle or something. You have to make sure, well, a square is a rectangle, that's a bad example. But just don't mix up your shapes. So this one, they have a bunch of information here. I know that this is 12. I know that BE is 8. AC is 10. ABC, which is this full angle, is 80. And then angle 6 is 45. This is what I know. And I'm going to fill in these blanks for what I don't know. So I am responsible for finding the length of BD. So BD is this full diagonal. So again, we're still working with a parallelogram. What we know about a parallelogram is only 4 things. We know the opposite sides are equal, the opposite angles are equal, the consecutive angles are supplementary, and that the diagonals bisect each other. Clearly we're working with a diagonal here, so the only property we can use is it's being bisected. So if I know that half of it, this little section right here is 8, the whole thing has to be 2 times that, 16. DC. DC is right here, all right? That is opposite AB, and so in a parallelogram, opposite sides are equal, so automatically that's 12. And then angle 5 right here. Remember, the only thing that I know about angles in a parallelogram, just a regular parallelogram, is that opposite angles are congruent and consecutive angles are supplementary. I know nothing else. I know other shapes, we know other things. I'm aware of that, and I know you guys, we've learned that. Other shapes, like rectangles and rhombus and square, have other things that we know about angles. Parallelogram does not, just a regular parallelogram. All we know is that opposite angles are congruent and consecutive angles are supplementary. So I need to use one of those, or both, to figure it out. So I know that this full angle is 80, and then the angle I'm looking for is 5. So 5 has no relation, it's not opposite 80. 5 is not across the shape, it's right next to or along the shape with 80. So I'm not going to do the opposite angles are congruent. Instead, I'm going to focus on the consecutive angles being supplementary. But 5 by itself, this little sliver, is not consecutive. I'm going to have to work with the full angle. That's why they gave me the angle 6 was 45. So this full angle, the 6 and 5 together, is supplementary with that 80. So to solve this one, I'm going to have 80 plus 45 plus angle 5 is equal to 180. Both of these angles together, the 45 plus angle 5 and the 80 are supplementary because those are consecutive. So one of those 2 angle properties is all you can do here because we don't know anything else besides this being a parallelogram which has those 2 properties. So when you solve that algebraically, you get 55. So do not assume anything else that we've learned about other shapes like rectangle, rhombus, square, anything like that. Do not force that on a parallelogram. The parallelogram is the one we know least about. So you can only use those 4 things. So be careful. Alright, next shape we're going to talk about is rectangle. So this one we still know those 4 things about a parallelogram. We also know that the full diagonals are congruent and that the corners are 90 degrees. So those are the other details we're going to add into our brains now as we're trying to approach this. So I have AD is 4, AC is 12, AB is 8, and this angle right here is 20. And now we're going to solve for this other information. So AE, which is right here, remember that a rectangle is still a parallelogram. So everything that we were just talking about is still true here. Opposite sides are congruent, opposite angles are congruent, consecutive angles are supplementary, diagonals bisect each other. We just also know a little bit more. Now for this first one, AE, I'm just going to use something I know about parallelograms. If I know that the full diagonal is 12 and I'm just looking for this section, that's going to be half. It's been bisected, it's been cut in half. So this part's just 6. So you can still use that parallelogram stuff. Oftentimes you will be just using the parallelogram stuff. It's the extra things like the corners being 90 degrees and the full diagonals being congruent. You can use those now too, but you can still use parallelogram stuff. All right, BD. BD is the second diagonal, the full length. Now this is what's special for rectangles. If this was a parallelogram, you wouldn't be able to figure it out because we don't know any relationship between the full lengths of the diagonals in a parallelogram. But this happens to be a rectangle. And in a rectangle, we know that the full lengths are equal. So I can say that BD is 12. Only if it's a rectangle. Okay? It's true for a rectangle, not just any random parallelogram. All right, angle 5. Angle 5 is right here. Okay? So remember, what we know about angles in a parallelogram, opposite angles are congruent, consecutive angles are supplementary. When you throw the fact that it's a rectangle in the mix, the third thing that we also know is that the corners are 90. And so that's what I'm going to use to help me. Because the only angle I know is 20, so I can't use the other 2 properties of a parallelogram. So the fact that that is 90, I can say that 20 plus angle 5 is equal to 90 degrees, and I can solve that way. So angle 5 would be 70. Can't use any other properties, they don't work for me. And then angle 2 is all the way up here. Okay, there are a couple different ways that you can find angle 2. One of them is that you can use half the rectangle like this. Right? If I know that corner is 90 degrees and I just found that angle 5 is 70, you can use that triangle. Remember, you can use triangles to help you too. So if I know this is 90 and this is 70, I can use that half of the rectangle, that triangle with the triangle sum theorem to get that as 20. Another way that you can do it is using parallel lines, because remember, a rectangle is a parallelogram, so the sides are parallel. So you could also do this. Right? If you know that this angle right here is 20, if you look really carefully, there's a Z. These sides are parallel, right, because it's a parallelogram. So the corners of the Z using alternate interior angles, those are equal. So that's another way you could get it. It's still 20. You should get the same answer no matter what method you use. Okay, so just make sure you're using something valid about a rectangle, and you should get the right answer. So that's that information. All right. Now we're going to keep going. We're going to find the value of x with all these different expressions here. So they're giving me BE and BD. So BE is right here. It's half the diagonal, and BD is the whole diagonal. So that you have to think in that way. BD is the full diagonal, and because the diagonals are cut in half, BE is half of that. Okay? So again, you have to use that property that the diagonals are bisected. So that means that if this is the full length and this is only half, I'm going to have to cut this 18 in half to make it equal to the 2x plus 3. So 2x plus 3 is equal to half of the full diagonal, which is 18. So if I cut that in half, it's 9. Okay? So, and there are 2 ways. You could either multiply 2x plus 3 times 2 to make it equal to 18, or just leave this alone and cut the 18 in half. You can either build up or break down, whatever. All right, so now what you do is you subtract the 3 and divide by 2. So with that question, you would get that x is equal to 3. I expect you can do the algebra. All right, this next one, AB, which is right here. Let me go ahead and erase this. So AB is right here, and DC is right here. So we are referring to opposite sides here. Remember, opposite sides are congruent, because this is still a parallelogram, so everything about parallelogram is still true. So the opposite sides are congruent, so all I have to do is set them equal to each other. Very straightforward question. All right, when I subtract and like that. I get that x is equal to 5. Okay, really straightforward stuff again. And now here we're working with angles. So we have angle 6 is equal to something, and then angle 5 is equal to something else. So again, when they're giving you this information, you just have to figure out what the relationship is between those objects. So angle 6 and angle 5, they're both together working to create a corner of a rectangle, and we know by definition that's 90 degrees. In a rectangle, it's a 90-degree corner right here. So both of those angles together, if you add them together, they make that corner, which is 90 degrees. So you just have to write that equation. They're complementary. They add together to equal 90, and then I'll let you guys do that algebra so I can move on. When you do the algebra, you should get 19. Okay? So that's our rectangle. Now we're going to move into a rhombus. So remember, for a rhombus, still a parallelogram. So everything we know about a parallelogram is still true. Opposite sides are equal. Opposite angles are equal. Consecutive angles are supplementary, and the diagonals bisect each other. You just also have to remember that the definition of a rhombus is that all 4 sides are equal. So not only are the opposite sides equal, all 4 of them are equal to each other. That's the definition of a rhombus. In addition to the extra information that the definition gives us, we also know that the diagonals are perpendicular and the diagonals bisect opposite angles. So you have to keep all that information straight. You have to keep it separate from everything else. We're focusing on rhombus right now. This is what's true for a rhombus. All right, so go ahead and put the information in. I know this is 13. I know this is 10. This is 12. This is 25. That's what I know. Okay, so now we're going to work with that information. So the first thing I want to know is DC. So DC is opposite the side AB. And remember, opposite sides in a parallelogram, rhombus, right? So rhombus is a parallelogram. They're going to be equal. So all the sides are equal, actually. So if you wanted to, you could just write 13 all the way around if you wanted to. So that's the definition of a rhombus, that they're all equal. So all those sides, DC in particular, is 13, R13, sorry. And then BD, which is right here, BD is the full diagonal. Remember, this is still a parallelogram, so the diagonal has been cut in half, and they gave me half of that. They gave me DE as 12. So if they now want the full diagonal, all I have to do is multiply that by 2 to get the full thing. So 12 and 12, because each of those are equal, equals 24 together. Angle 1. Angle 1 is right here. All right, now remember, for a rhombus, right, the definition of a rhombus tells us that all the sides are equal. I'm going to erase the numbers really quick, just so you can see the symbols. So I'm going to put those little hash marks there. All of those are the same. So what's interesting about a rhombus is because all 4 sides are the same. If you chop a rhombus in half, we have isosceles triangles. Remember, there are isosceles triangles in a rectangle too. They're just, remember, for a rectangle you can do this, right? So you have 4 smaller isosceles triangles inside of a rectangle. So don't forget that those are there and you can use those. But for a rhombus, half of a rhombus is isosceles, okay? Not the 4 pieces like a rectangle. For a rectangle, all these 4 sections are isosceles. For a rhombus, it's half. It's the larger picture here. So half of a rhombus is isosceles. So if I'm looking for angle 1, I can use the isosceles triangle theorem that tells us that the base angles are equal. So if I know this is 25, then this is 25. I'm now trying to find angle 2. Another property of the rhombus that's unique to the rhombus is that the diagonal bisects the angles. So if this is 24 and this is cutting the full angle in half, that means this has to be 24 as well. Right? That's one of the properties of a rhombus, not a rectangle, not just any random parallelogram, a rhombus. So these are both equal, so that's 24. I'm also looking for angle 4. Same thing up here. These 2 are halves. They're both equal to each other. So angle 4 would also be 24. I don't know why I wrote 25 here. I apologize. 24. All right, and then so all of these are the same. All right, opposite angles are equal, and then they've been cut in half, so all 4 of those little halves should be equal. Now I'm looking for angle 5, which is right here. 5 has no relationship to the 24s. Wait, you know what? I'm just goofing up all over the place. The original angle was 25, wasn't it? Yep, sorry. That's my bad. I had the original number correct, and then for some reason it turned into 24. I don't know why. Sorry. Okay, there we go. So all 4 of these, maybe that I kept saying 4, maybe that's what it was. So all 4 of these little angles, all those halves are equal. But 5 is not grouped together with those. 5 is part of a different angle. So to find angle 5, I work a little bit differently. There are a couple different ways you can do this too. The easiest way to do it is look to see, so I know half of a rhombus is isosceles, but what if you break it into fourths? What if you break it into the 4 triangles? Well, those triangles are not isosceles, don't think that, but they are right triangles. Remember, the other property of a rhombus is that all the angles in here are 90, okay? So if I do that, and if I just look at a fourth of the rhombus, just this little quarter right there, I have a little triangle that looks like this. I know that 90 is right here, 25 is there from a previous question, and I'm just looking for this guy right here. So you can just use triangle sum theorem. Add the 90 to the 25, subtract that from 180, and you would get 65. Okay? And there are other ways to do it, but that's the easiest one to explain. But if you see another way, feel free. As long as you get 65, it was a valid method. All right, and then the last 2 angles, I want DEC. DEC is right here. Remember, the diagonals are perpendicular, so any of those angles in the middle where the diagonals are crossing, those are 90, because they're perpendicular. And then the other angle is DCB. Okay, so they want, oops, just gonna erase this because it's getting messy here. All right, they want the measure of DCB, so they want this full angle right here. So that's a full angle, and previously we knew that angle 1 and angle 2 are both 25 separately, so that makes this angle 50 total. So if they want that whole angle, this time you guys are going to be using one of the properties of a parallelogram, that the consecutive angles are supplementary. You can even use this one too. This one's also 50, right? This one's also 50 together, because you knew, again, that they were both 25, so if you combine, it's 50. So again, the consecutive angles are supplementary. So if either one of those is 50, to make the full 180, that would have to be 130, because they're looking for the full angle. All right? So again, I know it can be a little bit complicated, especially when they have a lot of information in one picture. You just have to redraw it or erase and write only relevant information, whatever. But just make sure you know the properties of a rhombus and how to use them correctly. The next shape we're going to talk about is isosceles trapezoid. All right, so with it being a trapezoid, by definition, these are parallel because it's an isosceles trapezoid. Those 2 legs are equal. I know that DAB, which is right here, that is 120. AC, which is this full diagonal, I'm going to draw a little arrow, that's 11. I know that AD, which is one of the legs, is 6, and I know the slope of one of the bases is -1/2. I want to solve for BC. BC is the other leg in an isosceles trapezoid. They are equal. So if one of the legs is 6, the other one is also 6. Very easy question. I now want to find ADC, which is right here. Remember isosceles trapezoids. In every trapezoid, the leg angles, so the ones that are on the leg here, the ones that are between the parallel lines, those are consecutive interior angles, which makes them supplementary. So this being isosceles trapezoid doesn't make it too special, because this is true for every trapezoid. But if I know that this is 120 and I'm trying to find this, they are supplementary. So I would do 180 minus the 120, and that gives me 60. Okay, so if they're the leg angles along the side here, between the 2 parallel lines, they're consecutive interior, supplementary. Next, I want to find BD. BD is the length of this diagonal. I already know one diagonal. In an isosceles trapezoid, the diagonals are equal, just like a rectangle. So if this diagonal is 11, the other one is also 11. And then lastly, I want to find the slope of the other base, DC. The top base had a slope of -1/2, and because they're parallel, they have to have the same slope. So the bottom would also have a slope of -1/2. All right, lastly, we're going to talk about the kite. So color code is best. So remember that little system I did in the notes? Because the major diagonal bisects opposite angles, these 2 angle pairs are equal. These 2 angles are equal because of the isosceles relationship. Remember, the 2 top sides of a kite are equal and the 2 bottom sides are equal. So we have 2 isosceles triangles there, and then, oops, that's not what I wanted. And then these 2 are equal as well by the isosceles. So make sure you have, if you want to bring colors to the test, feel free to do that. And then the sides, also measure the sides. So these 2 are equal, that's why the 2 pink angles are equal. These 2 sides are equal, that's why the green are equal. And then the shorter diagonal is being cut in half as well. So all that information is important. One more thing to put in here is that those are perpendicular, and you now know everything that you need to know about a kite. Okay, that's everything we know about a kite in the picture. The top sides and bottom sides are equal, the diagonal has been bisected, they're perpendicular, and then all those angles are equal. So that was all that up there. We're just going to go ahead and solve. So the first angle I want for question 33 is AED. AED, okay, so that's this angle right here, by the property of a kite being perpendicular diagonals, that's 90. Next, I want EDC. So EDC, that's this bottom green, the left green angle. I don't know if you guys can see it, but it's this angle right here. Okay, the only angle that I know right now, I didn't put that information in, sorry. The only angle I know is DAB, so that's up here. This is 80. And then I know this full angle is 120. That's what I know. Okay, now I'm trying to find this green angle. Now I know you guys are going to be tempted to see that the full angle is 120 and I just want this. You're going to be tempted to divide it in half. But look how I color coded, and this is why I think color coding is important. Do I have two green dots right there? No, I have a pink one and a green one. So clearly those are not equal. Those are not equal to each other. So you can't just divide 120 by 2. You can't. Because these two are equal, but those two are not. Okay? So you can't just cut it in half. The color coding will warn you not to do that if you're really paying attention. So instead, I'm going to have to figure out what those angles are separately and kind of work backwards. So the only other angle I know is this 80 up here. So what's really interesting is that the full angle is 80, and I see two blue dots. So that means those two angles are equal. So if I know the whole thing is 80, that means each little section here is 40. So I'm going to write it like that. Instead of saying the whole thing is 80, I'm going to write 240 separately. And now, I can, since I'm looking for the green, I can actually find the pink, and that will help me. And so if you look at the upper left triangle, the upper left triangle looks like this right now. I know this is 40, I know this is 90, and the pink dot is right here. If I can find the pink dot, I can subtract that from 120 and find the green dot. Alright, so use triangle sum theorem. If I do 90 plus 40 and subtract that from 180, this pink dot right here is 50. So if I know that the pink and the green together is 120, and I just want the green, subtract 50 from 120, and that leaves me 70 for the green. Okay? I know that picture's getting a little crowded, so just bear with me. So that's that angle. Now they want DAE. So DAE, we found that one previously. We had to do that in order to find the angle from the previous question. So DAE is that left-hand blue dot, which we said was half of the 80, so it's 40. Then we want ADE. Again, we found that previously in order to help us with the other question. That pink dot is ADE, and we already found that that was 50 using this triangle, right? All right, and the last angle is ECD. ECD is this left-handed red dot in the picture. So that's using this triangle, the bottom left. Again, using triangles in a kite is bad. Almost always just going to chop it up into triangles and see how they work. And they don't even have to be just the one of the 4 triangles. You can use half of the kite too. So break it up into any triangles that are helpful. But in this one, I know that this was 70 from a previous question, and that's the angle I'm looking for, that red dot. So if you do 90 and 70 subtracted from 180, you're left with 20. Okay? That's the basic algebra. And then the next thing I want to do is find AD. So in the kite, I know this is really messy up here, but AD is this side right here. I know that this side is 3 and this side is 5. So again, if you guys are trying to find sides in a kite, it's almost always Pythagorean theorem. Sometimes it's the special right triangles like the 45, 45, 90 and the 30, 60, 90. But more often than not, it's going to be Pythagorean theorem. So what I'm going to do is I have this triangle, I have this one with AB. I know this is 3 and this is 5. Okay? I can use Pythagorean theorem, again, because that's 90 degrees. I can use Pythagorean theorem to find this side, and then I can use the definition of a kite to say that that's equal to the side I was looking for on the other side of the kite. Okay? So Pythagorean theorem, if I call this x squared is equal to 3 squared plus 5 squared. 9 plus 25 is 34. So this side right here, AB, is the square root of 34. And because a kite, these two sides are equal, I can say this side is also the square root of 34. Okay? So again, Pythagorean theorem, be prepared to use that. You could have also said that because the diagonals, or sorry, this diagonal is bisected, you could shift the 5 over here and just use that left triangle and get it more straightforward that way. Either way is fine, as long as you use Pythagorean theorem. All right, we're done with that. Now we're going to move on to the coordinate plane stuff that we talked about on the same lesson as the trapezoid and the kite. So for this one, it's a little bit different. In our lesson, I gave you all 4 points and asked you what shape it was. This time I'm giving you what shape I want it to be in 3 of the points, and you have to find the 4th one. So I have negative 2, 0. I have 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6. Yep. And then, oh, I skipped 1, 2, 6. Wait, 1, 2, 1, 2, 3, 4, 5. Okay. So I have this, and I want to know where D would be to create a parallelogram. Okay, so clearly you guys can see it. We're kind of connecting the dots. This is what I have so far. That's what I got. I need to figure out where D should be so I can finish out a parallelogram. Now remember, for a parallelogram, what we were doing in this lesson is that the first thing you want to do is pay attention to slope. Slope is the first thing you want to look for, because when we're trying to figure out what kind of shape it is, the first thing that will help you is figure out are the sides even parallel, because that can help you figure out here. So I want the sides to be parallel because it's supposed to be a parallelogram. So clearly this is flat, so the other side has to be flat, right? So it has to be along here. To get this bottom side to be flat, it has to be along the axis, right? If I had it like up here, this opposite side wouldn't be parallel to that, okay? So this slope right here has a slope of 0. Oops. This has a slope of 0, so we want the other one to have a slope of 0. And then this one has a slope of 1, 2, 3, 4, wait, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, so 6 over 4. Went up 6 over 4. So I want to just mimic that. I want to find what point would I have to be at so that it has a slope of 0 here, but a slope of 6 over 4 to go from that point up. Okay. So what I'm going to do is I'm actually going to do the reverse. If I went up 6 and over 4, I'm going to do the reverse of that. I'm going to go down 6 and left 4. I'm going to just kind of go backwards to see where I end up. So from here, if I go down 1, 2, 3, 4, 5, 6, and over 4, 1, 2, 3, 4, that is the point I want. Okay? This is a slope of 0. This is a slope of 6 over 4. Right? So it matches. So that point I wanted is 1, 0. Right? You can use slope. You could also see that opposite sides are supposed to be equal. So this side right here is 1, 2, 3 long because it's horizontal. I want this one to be 1, 2, 3 long. So now I have opposite sides are congruent too. You could this one's slanty, so to find the length you have to use distance formula, but if you use the flat ones as a reference, these are both parallel and congruent. Remember, that was one of our special properties to show something is a parallelogram. If they are both the same measure or the same length and parallel, it's a parallelogram. So that's the point I was after. But using slope is usually something you can do more easily. All right, this one is now a rhombus. We want the point C to make sure that this is a rhombus. So I have these points all in here. So let's go ahead and look at slope again. So the slope of, the slope of this side, I went from negative, unfortunately it doesn't have a graph, so it's harder to count. But if I'm going from negative 2 to 1, I have to go up 2 and then up 1. So go up 2 to the axis and then up again. So I went up 3, and then I was at negative 2, and then this is going to 2. So I had to go 1, 2, 3, 4. So I have to go from negative 2, sorry, I did the y's and the x's differently. I'm sorry, I did that backwards. Okay, sorry. I'm trying to make this video short, so I'm rushing a little. But the y values are here, guys. That's the y value for a point. Sorry. So for the y's, sorry, I was at negative 2. I go up 2 to the axis and then up 2 again. So it rises 4. There we go. And then the x goes from negative 2 to 1. That's the 3. My bad. I had those backwards. So this has a slope of up 4 over 3. This side right here, because this is the one that has the numbers, we're staying level with the y. The y didn't change, so I'm just going flat like this. So that's a slope of 0. If it's just a horizontal line, the slope is 0. And then, so those are the only two that I know because I don't know what these numbers are. So I don't know this slope or this slope yet because I don't know what C is. But remember, for a rhombus, I want it to be a parallelogram. That's the first thing that I need to make sure is happening. So the slopes do need to be the same. So I need this to be a slope of 0, and I need this to be a slope of 4 over 3. That needs to happen because this is a parallelogram. In addition to it being a parallelogram, I also need the sides to be congruent. Remember, all 4 sides should be congruent for it to be a rhombus. So if I take a look, if I look at this side right here, I can see that it's horizontal, so I can just count how far I went on the x-axis and see how long it was. So if my original x started at -2, and then it went -1, well, it went from -2 to 3. So it went 2 to get to the axis, and then 3 more to go out. So it was 5. If you have graph paper, you can use that to help you too. But to go from the -2 to the 3, I had to move 5 over. So this, its length, is 5. Its slope is 0, its length is 5. So if I want this to be a rhombus, I need to make sure that this is also 5, because the opposite sides need to be equal, just like all 4 of them have to be equal. So if I look, I'm starting here at 1. If I need to go 5 over, where would I end up? Clearly at 6. So in order for these 2 sides to be the same length, they have to be 5 each. To go from 1, if I move 5 over, that gets me to 6 on the x-axis. Now I have to figure out the y. So I can use the slope to actually figure that out, just like we did over here. When we were trying to get the sides to be parallel, I can do the same thing here. So I know the slope from this point up to this one has to be 4/3, so I need to go up 4/3. So if I am at a y value of -2 and I need to go up 4, that means that I match the same way that I went up 4 here. So the y value has to be 2. Again, the slope has to be 0 here, so the y's have to be the same. So again, use slope. If I'm going from here to here the same way I went from here to here, I just go up 4 and over 3, just like I did for this side. So you can use the same method that I did over here, using slope to verify that, especially since the slope was 0 along both sides. So your point would be 6. If you guys need graph paper, you can ask me during the test, but I think the one that we have actually has the graph built in. All right, last page. Okay, this one is the mid-segment formula. So it's just like midpoint. Remember, midpoint is when you add things and divide by 2 for the x's and the y's. This is not a point. These are just 2 bases. But it's the same idea. You're going to add the bases and divide by 2 to find the mid-segment. This one's the mid-segment right here. I'm going to change colors. This is the mid-segment. So if you add this and divide by 2, you get that. So I'm going to say so the formula is this. You just want to write it out. And now I'm going to plug in everything I know. I know what the mid-segment is, actually. I already know what it is. What I'm trying to do is solve for x. So I know the mid-segment is 30. That's going to be equal to the 2 bases added together times 1/2. So we had a question like this in the notes. We're trying to solve for x using this formula, so I'm going to multiply the 2 over, that gives me 60. I'm going to combine like terms. I'm going to subtract the 4, and I'm going to divide. There you go. Alright, so that's just it. That stuff's pretty easy. You guys should know how to do that. It's a mid-segment formula. Just know where to plug everything in and do algebra. Alright, this next question here, 43. This is actually going back to our day 1, so this is more angle stuff. So this is a 1, 2, 3, 4, 5-sided figure. It's a pentagon, and that doesn't really matter. We are focusing on exterior angles. You should notice that the majority of the angles they've shown us are exterior, specifically the angle that they want us to find. So we need to think about what we know about exterior angles. Well, really the only thing we know is that they all add up to 360, and that if it's a regular shape, you can find one of them by dividing by n. This is clearly not a regular shape because the angles and the sides are not the same. So instead, I'm going to be using the sum. I'm going to find what all of the exterior angles add up to, and then solve for x. Or because they do add up to 360, I can write that as an equation to solve for x. So I have x here, I have 52 here, I have 76 here. Now what you have to pay attention to is that these 2 interior angles, remember, interior angles have a relationship to the exterior angles that are a linear pair. So even though I don't have anything written here, I know it's 90 because they're a linear pair. So I also have a 90 right here and a 90 right here. Those are extremely easy to miss. You have to make sure that you're paying attention. Just because you don't see a number there doesn't mean you can skip over it. You need something written for every single one of our exterior angles, and if you have to use linear pair to do that, then do it. Okay, so I have 52, I have 76, I have 90, I have x, and I have another 90. All of those add up to 360. Sorry, I was running out of room. Okay, all the exterior angles in any polygon, no matter what, always adds up to 360. All right, so then when I add those together, 1 second. All right, when I add the numbers that I know, the 52, the 76, the 90, and the 90, that gives me 308. Oops, oh my gosh. All right, I know this. I know that these angles all add to 308. I'm going to subtract that away. X is 52. Okay, so again, for this one, you have to use the sum of exterior angles and then use some algebra to solve. Now this one, it's very similar, right? The x that I'm looking for is an exterior angle. The difference here is that this is a regular shape. Regular shapes have equal angles and equal sides. And you notice all the angles are equal, all the sides are equal. So this is a regular shape. For this one, we're allowed to use that other formula, the one where you divide by n. You're only allowed to use that one if it's regular shape, and we have a regular shape right here. So I'm trying to find one exterior angle. That's why they didn't give me any other numbers, because it's one exterior angle and we have a formula for that. So this is just like our word problems. It's just not in words. They do the picture for us. So in words it would be, what is one exterior angle of a regular octagon? Because it has 8 sides. So it's the same thing as a word problem, they just represented it in picture form. So what is one exterior angle for a regular octagon? Well, it would be 360 divided by n, but n is 8 because we have 8 sides, 45. So the angle itself, the full angle here, is 45 degrees, but we need to solve for x. So they said the angle was 3x, but we know its measure is equal to 45, so I can write a little equation right there. It's both 3x and 45 at the same time, so set them equal. And then when you divide, oh, it's wrong on the answer key. My apologies, guys. I just wrote the 45 and left it there. It should be 15. I actually need to do 3x equals 45 and then solve. So the angle, the full angle is 45, but the x is 15. So I'll have to fix that on the answer key. Okay, and then 45, it says, how can you mathematically tell if a regular shape will tessellate? That's in your notes. Something I asked you guys to put a star next to or highlight. The way that you tell if something will tessellate is by finding one interior angle. Find an interior angle and see if it divides evenly into 360. Alright, so if I ask you, does a regular pentagon tessellate, you would have to find one interior angle, and then whatever that number is, you do 360 by that, divided by that number, and see if you get a whole number. If you get a decimal, that means it didn't work. Okay. So just that's highlighted in your notes, one of the little statements that we have on tessellation, so make sure you remember that. Now these next questions are a little bit trickier. They're related to the e-cart questions you guys might see. Actually, I don't know if all of them are e-cart, but still they're important to understand. So this next question says, what is the measure of y, an exterior angle, to this regular polygon? And then once you know that, how many sides do you have? So it's important to recognize that it says it's regular. So because it's regular, it means that all the angles are the same, all the sides are the same. So they're trying to get us to find this right here, but all we know is this. Okay? This is one interior angle. Now, notice how they said it's a regular polygon. So even though the 140 has been drawn right here, I can move it over and say that 140 also is this angle. Because remember, in a regular polygon, all the angles are the same. So if I know this is 140, this would be 140. Then the next one would be 140, and the next one would be 140. So you can shift the 140 over here, and then remember, important relationship, the exterior angle and the interior angle are a linear pair. So y would be 40. Because together, they're supplementary. That's what a linear pair is. Alright, so you use the interior angle to help you find the exterior. They're a linear pair. Now that I know that one exterior angle is 40, I can use that solving backwards trick. Remember, anytime they want to know how many sides does a polygon have, that's the backward solving, where you pick what formula am I using, and then you solve for n. So I know one exterior angle. One exterior angle. The formula for that is 360 divided by n. And we're allowed to do this because it's a regular polygon. So one exterior angle is 40. Okay, so this is the formula I'm using because it's one exterior angle, and I know what the answer is. I have to solve for n. So you would multiply the n and then divide by 40. So 360 divided by 40 is 9? Yeah, 9. So this has 9 sides. Right, so it's a two-part question. Find the exterior angle and then use that to find how many sides you have by solving backwards, like we did at the very start of this review. Next one, what is the measure of y in this diagram? So there are two y's, which means that these two angles right here are congruent. So I'm going to use both of those angles at the same time to solve for y. This is kind of like a tessellation question. Not exactly, but sort of. So notice how I have these two angles that are both y, and then I have this angle right here, which is one interior angle of a regular hexagon. So again, keyword regular, and they gave me what shape it was. So what I'm going to do is notice how all three of these angles together make this nice straight line. So it means all three of these together, when they form that line, they should all add up to 180. So I'm going to have the y, this angle, plus this angle that I don't know right now, plus the other y. All of those together, when you combine them, equals 180. I just drew my y's two different ways. That's weird. All right, so what I need to do in order to solve for y is find this angle. Okay, and we saw this in the tessellation stuff. When you have questions like this, if I want to know this angle, I just need to find one interior angle. I don't need to know all of them. I don't need to know the sum. I need to know one interior angle, and it happens to be regular. So when you're looking for one interior angle of a regular polygon, that's this formula. Divide by n. Or you can only do that when it's regular, and they told me it was. So if I'm trying to find one interior angle, this guy right here, I'm going to use that formula. So it's 180 times 4, because a hexagon has 6 sides. 6 minus 2 is 4. And I'm going to divide that by 6. So inside of the hexagon, that is 120. So this angle is 120. Right? So when you're stuck like this, you're like, gosh darn it, in order to find y, I know that they all equal 180. In order to find y, I need to know that angle. We'll think back to lesson 1. When you guys are trying to find an angle within a triangle, just make sure it's regular, and then use that formula. So now I just solved, you would subtract, you have 2 y's, when you subtract that, you get a 6, so then y is 30. So you have 30, 120, and then another 30 equals 180. Cool. All right, don't do 48. I don't like that one. Not needed, not necessary, forget it. All right, this next one is just like the one we just did. So this one's very similar. I'm trying to find x, which is this little angle right here, and I'm going to be using the angles all around to help me do that. Okay, so this is, again, related to tessellation. All these angles are meeting at that one point, and then all the way around a point makes a circle, and all the way around is going to be 360. So all of these angles, this one right here, this one right here, this one right here, and x. So x plus these three angles that I need to know what they are. This one, this one, this one. Those should all add up to 360. It was 180 for the other question because it was just a line, but these ones make a full circle going all the way around. Okay? So now I need to find what those three angles are. Well, they've told us that we have squares and a regular pentagon. So squares, I can easily, those are 90. You guys should know that automatically. And then the other one's a regular pentagon. Because it's regular, I can use this formula to find one of the angles. Right? It's always going to be regular when you guys are doing tessellation. So if you need to find one of those angles, you're allowed to do this. The shapes will be regular for you. All right, so then this is a pentagon, so I'm going to plug in 5. So it's 180 times 3 divided by 5. And one interior angle of a pentagon, I have that memorized, is 108. If you don't have it memorized, obviously you have to use the formula. All right, so I have the 90, the 90, the 108, and then the x, all of those together to create that full circle all the way around that point of intersection equals 360. So if I add those to that, subtract away into the 360, I'm left with 72. So x is just 72. Right? So all that we just did, you guys need to make sure you understand the day 1 formulas for angles, interior and exterior, looking for the keywords, knowing when you're allowed to use them, how to use them forwards and backwards. You need to know all your properties for the shapes we've learned. Don't mix them up. Don't think that something that's true about a rectangle happens for a rhombus or vice versa. You need to make sure you know all the properties and know when to use them and when not to. And then you need to know your tessellation stuff, as well as the kite and the trapezoid. There are also going to be a couple of review questions, so I have them in this box here, things that you need to remember from previous units. that will be review questions on the test.